Okay, we'll get started. Okay, so a couple of logistical things. Because I asked you to do a double lecture uh, online uh, with the social engineering, this will be the last lecture. Okay, so we'll end the course a week early, and so there won't be a lecture next week. What else? Course evaluations. So please do the course evaluations. It's actually helpful. It's helpful for me. It's helpful for the department. I do read them and I take them seriously. And a lot of the things that you see that hopefully are helping you is a direct result of course evaluations. For example, I record all my lectures. I put them on YouTube. If you miss class, you can follow along. Why do I do that? Well, it was a suggestion that someone made once upon a time in the course evaluations. And so, yeah, anyways, a lot of things have sort of evolved as a result of that. So take the time to fill them out. What else? Okay, so final exams. Yeah? Anyone have any questions about that?
At the end of every class, I try to think what could be possible questions that will come out from this topic because it's not very direct. It's like perspection,
Yeah.
things, the different ways the same thing will be done. And I was just thinking, how is the exam is going to look like?
Okay, so it's a great question. Okay, so yeah, so first off, I'll reiterate the sample questions. I just put them up because every year students were bugging me, like, give me sample, give me sample. So I just threw an exam on. But it's like old, and there's a bunch of topics that are there that aren't even covered at all. So some of the questions are still relevant, but anyways, it's I wouldn't spend a lot of time on it myself personally, but it's there. Okay, so what would you expect in terms of questions? First, let me do the easy stuff. So like, what's the structure of the exam? So the exam will consist of short answer and multiple choice. It will be mostly multiple choice. By the way, bring a pencil. You'll do the multiple choice on Scantron. So that's like the forms like where you circle, you make the dark marks. And yeah. But then the short answer you can also write in pencil as well. You don't have to. Some people think that you have to write in pen or something like that. But I'm taking your exam sheet at the end of the day, so you can do that in pencil. In fact, I would encourage you to do it in pencil because then you can erase and change anything that needs to get changed. You can bring a cheat sheet. So the first kind of question I will not ask you is a memorization question. What does STRIDE stand for, the 6 things in STRIDE? Like, there's going to be none of that, okay? I assume that you're going to write that kind of stuff on your cheat sheet, and so that's, yeah. So you don't have to strictly memorize anything. If you are worried about not remembering, then just put it on your cheat sheet, okay? Cheat sheet can be just one piece of paper. It can be double-sided. You can write really small and bring a magnifying glass. It doesn't matter. It's not really about the size of the paper. It's just, I limit it to one sheet because I don't want people like ruffling around and it gets noisy. Yeah. Okay. The questions themselves. Okay. So you're thinking the right way because it's actually really hard to write exams for this class for the reason that you pointed out, which is there's a lot of stories, a lot of narratives, a lot of like different structures, different methodologies and things like that. I can't really get you to apply a methodology in an exam. It's too involved. Like the kinds of things that you did in the assignment, like that's not it would be too time consuming to do in an exam. And you can't really do that in like under pressure, I would say. Those are the types of things. So don't expect like, oh, do a cognitive walkthrough of this or do an evaluation framework for this kind of thing. So it won't be those questions. So the main kind of question, probably, I don't know, like 90%, will be scenario based. So the question will be like, I don't know, Alice wants to sneak a bomb onto an airplane, which what are the possible ways she could do it, or like what's the one way that she could do it that seems to work. So it could be like, I don't know, she puts a bomb in her shoe. She makes a liquid bomb with contact cleaner, and it's over 100 ml, but she tries to put it on the plane anyways. And that might be the right answer because there's that loophole in it. So it's something that was tied directly to the lecture. You would understand the answer from knowing the material in the lecture. But anyways, it will be a lot of scenario-based things, like Alice wants to do X, Y, Z, and then something from the lecture. Yeah. And so in terms of studying, the most important thing is actually that you understand the course. I mean, that should be the natural thing anyways, but like I would spend all of your time like just going over the material and just being like, do I really understand it? Not could I repeat it to someone? There's a difference between like I could repeat it back to like I actually understand it. I know what's going on. I could explain it myself. I could explain it to a friend if my friend came and said I didn't really understand. Like there's this cross-site forgery thing. Like I don't really get that, But like if you understand it at the level that you could explain it, then that's what you need for the exam. You'll do well in the exam. Yeah. Okay, so all of this might sound like the exam is really easy. Most students find my exams hard. I don't know why. They're easy for me. No, but anyway, but that's not to stress you out. It's just like don't kind of brush it off like, oh, it's just going to be a bunch of multiple choice questions that are just about what Alice should do, and like I'll try really hard if I give you a multiple choice to make it sound like every 4 option sounds like the right answer. And so you need to think about, and it's sometimes it will be between the lines sort of what we taught in class or whatever. But anyway, so the main thing is to just sort of ground yourself in the material itself, and that's the best strategy I have for studying for it. Yep.
Just like the same question that you said, like Alice takes a bomb onto it, like how would she do it? For that question, let's say I come up with something that you have not covered really in the lecture. For example, like this one place I read, a way to do that would be to actually, like those waxing things, like those strips, you can like pick up certain types of material onto it and like smuggle it onto the plane and then just do something with that. That's one method, but something that we have not covered in the lecture or something that is not in the material. So how would that be marked?
Okay, so it goes into whether that would show up in a short answer question or in a multiple choice. So in a multiple choice, that just wouldn't be an option, right? And most, like I'll emphasize that most of the exam will be multiple choice. Like 80% of it will be on multiple choice, and maybe 20% or something like that would be short answer. If it showed up in a short answer question, I accept anything that you say that's right, whether it's from the course or not. So I'll read it. If it makes sense, you'll get the marks. It's that simple. Yeah. So you're free to think outside the box of the course. For those types of things. Let me just make sure I covered all this. Okay, so I think this class is pretty big. I think we're split into 2 or 3 rooms, might even be 3. At some point, I'll post. I'll try and do it sooner rather than later. But first off, I don't know that you have the room numbers. I think for some reason they don't put it on the schedule. But anyways, I'll just add it on Moodle. So look on Moodle and you'll see like what room. Usually I just do it by last name. So if your last name is between A and D, you go to this room. If it's between D and M, you go to another room. That type of thing. Okay. So that will tell you where to show up. It's a 3-hour exam. I don't do super long exams. Some people like you're sweating for 3 hours. I try and give you like space to think because the questions are more conceptual. And so the fastest students sometimes finish in 45 minutes or less than an hour. But there's always students that stay for the full 3 hours as well because they just want to think about things. So it's fine, but it's not going to be one of those exams where there's just millions and millions of pages and your main challenge is getting through the material rather than than answering correctly. So you can take your time. I hope that's correct for you, and think about the questions. Multiple choice will be done on a Scantron, so bring a pencil. You can have your cheat sheets. If you're uncomfortable with English, you can bring a dictionary. That's fine. And you won't need a calculator, but if you go everywhere with a calculator, you can certainly bring one. That's fine as well. Okay, any other things that I can answer short of what's on the exam that would be helpful for you? Okay, anyways, think about it. We can circle back to this topic at the end of class 2 in case some new thing pops into your mind. Okay, any other logistical issues? There is one that.
For short answers, how short the answers are going to be?
Uh,
Sentence, word?
sorry. Yeah, it could be. So I haven't written the exam, but based on past years, it would be more like a short answer might have, say it has 4 marks. First off, if you look at the number of marks, that's like what I'm looking for. So like if you see like it's 4 marks, I'm looking for 4 things. So that might be 4 words, or it might be 4 sentences, kind of thing. Yeah. But like 4 ideas or whatever that you need to deliver. And so it depends on the question. Yeah. So in some cases, it might just be a simple. Sometimes it's like actually like. Not usually, but maybe like if it was like a networking, there's like a cookie value or something like the value might be the answer to the question or something like that. Yeah. So yeah, short answers are usually pretty concise. It's not, I don't want essays, or that would be what I consider a long answer. I won't ask long answer questions, probably. Yeah.
So is there any negative marking?
No, there isn't. Yeah. So you can guess freely, and yeah. I've tried negative marking in the past, but yeah, students don't like it. So actually the story of the exam is, so I used to do just pure short answer, and then one time the final exam was like, it fell exactly when my wife was expecting a baby, and so I was really scared that the baby would come before the exam, or I would have a huge pile of marking. So that year I was like, okay, I'm going to do a pure multiple choice exam. Like pure, 100%, no, nothing else. And but I was terrified that everyone would get 100 or get 70% or whatever. And so I used negative marking, and then the average on that exam was like 30% or something really, really brutal. But everything got belled up. It was okay. I had a ranking of students, so that like is the most important thing. So anyway, so I don't do negative marking. Yeah, it's. And yeah, on the evaluations, students didn't like it either. So I pay attention to the evaluations. Actually, no, that's a lie, because actually, I guess you have to do the evaluations before the exam. So I guess that wasn't a thing. But. Okay, other questions? Okay, how's everyone's projects? When are they due? They're doing well? Yeah, they're due last class. So today's the last class, right? Everyone knows that the project's due today because it's the last class. I'm just kidding. I'm not kidding. No, it can be the original. Does anyone want more time? Yeah? How much time do you want? Okay. All right. Anyone want more than that? Okay, let's do 1 week. So they were due next Wednesday. We'll make them do the Wednesday after. So technically, I'm not allowed to accept things during the exam period, but I'll phrase it as I will mark it without penalty if it comes in by December 4th. Without penalty, yeah. So basically, it's due then. It's just, yeah. Okay, I might regret saying this, but if, like, I really want to get the project off of you, that's my end goal. If things come up and you can't do it by that day, like, it's not, this isn't like undergrad where it's like the TA standing by the lockbox and you have to put the project in and then they walk away and then everyone gets a 0. Like, it's not like that at all. I just want to get a good project from you, okay? So if circumstances arise and you're like, I need another day or another 2 days, like, I'm very, very flexible. Just let me know ahead of time, okay? So yeah. And that applies to this class. If you're in my other class, it doesn't apply to that class because I gave a very, very long deadline. And in the other class, I actually need them by that date because I have to start marking them. So just for the few of you that are in both classes. Okay, are there anything else logistical before we go into the last lecture? No? Okay. Okay, so we'll wrap up the course. We're going to go through another security policy very similar to last class. So last class we looked at the cookie policy in browsers. This is just another complementary browser policy. It's kind of the same flavor. You'll see that a lot of cookies, some of the rules about cookies were like kind of what was the origin of the website that was setting it, and so this is going to be similar in flavor, but it concerns. Well, you'll see, but it concerns like JavaScript and things like that instead. Okay, so Netscape, one of the earlier browsers in '94, they're the ones that came up with all the cookie policies that we talked about last class. Okay, and cookies themselves. So before that, there were no cookies. So Netscape invented it, and then everyone sort of copied it once Netscape had it. Then the next year, they came up with something similar called the same origin policy. And in this case, it's for another like kind of security critical task, which is how do you manage scripting? In particular, when you have websites that are sort of weaving together content from lots of different places. Okay, so you saw this picture last class, but I'll just recall it. When you ask if you ask for like index.html from a web server, you're going to get all these packets that come to you, okay? And a bunch of them are just going to be about networking and routing and things like that. But once you go into the packets and now you're just looking at the web stuff, the HTTP stuff, you'll see that first off, there are some headers. Okay, the headers are like where the cookie value would be included, or if it's coming from the server to the client, it would be where the set cookie kind of command would be. And then you have the actual content, what you can see on the website itself, okay? So today, last class, we were here. This class, we're only going to be here in the content itself. And there's passive and active content. Passive meaning things like text, images, audio, HTML, that type of thing. Basically things that can't run code, they can't execute code. And then you have your active content, which are things that could be executed. And JavaScript is the main one that we'll talk about. So from now on, we'll just talk about JavaScript. But it could apply to other things. There are some more like obscure kinds of executions that used to happen in browsers. A lot of them have been discontinued. But things like Flash was something that was used, ActiveX, things like that. So that they're all like things that are active content. But because JavaScript has become so powerful, basically, and because we have HTML5 as well, so the invention of those two things, you can do now everything that you would want Flash for, or you want Ajax for, or something like that. So no one uses those technologies. Sorry, not Ajax, but ActiveX. Okay, so the same origin policy. The goal of the same origin policy is we are going to potentially be in the case, well, we're in one of two cases. Either all the resources that we're getting are from the same website. I go to Wikipedia and everything I'm looking at was given to me by Wikipedia. All the pictures, all the scripts, all the text, everything, okay? So it's a single origin website. And in that case, I don't really have any decisions to be, there's no decisions to be made, okay? The complexity is when I get some stuff from Wikipedia and then Google's throwing in some other stuff and there's an ad library being loaded from somewhere else. And so now I'm looking at a website where all the resources are from different origins. And I'm trying to figure out how do we isolate the various elements on the page, if at all, okay? Can everyone see everything else or do we want some sort of isolation in terms of it? So I'll be a little more concrete about what that means as we go through the material. Okay, so mechanically, when you go to a website and your browser downloads all the resources, first off, you can see that kind of thing. So if you go here, for example, let's use Wikipedia. So Wikipedia is actually a very clean website. So you can see that these are, we've seen this before when we talked about fingerprinting websites and the sizes of things and things like that. But these are basically all the resources that are on this website. So you have some images. I guess it's maybe a little small to see, but yeah, you have image types, you have JavaScript, you have fonts and layouts, you have the HTML file itself, and so you have all this stuff. Okay, so, and then what your browser is going to do is it's going to say, okay, where did I get this from? Okay, what was the origin of each of these things? And so you can see here there's a bunch of origins. So there's n.wikipedia.org, there's upload.wikipedia.org, and basically everything you see on this website is coming from some Wikipedia domain. Not every website is like that, right? Usually most websites would be like a whole mess of things from all sorts of different domains getting blended together, okay? Now, an origin and a domain are not exactly the same thing. We'll go through that in a second, okay? But you can think for now like an origin kind of being like a domain name, but it's going to be a little more specific than that. Okay, so then what your browser does is it takes all of those resources and it stores it, basically. As long as you're on the website and you're looking at the website, then it has it at its fingertips. So it sort of knows what all the resources are, and it kind of groups things. It groups them basically by origin. So the stuff that came from one origin gets grouped together, and the stuff that came from other origins get grouped together. The exact data structure is called the DOM tree. That doesn't really matter so much. But anyways, it's basically just a data structure that holds it. Again, if you want to see the DOM tree, you can see it here somewhere. So this is kind of, there's a way to like sort of see the tree bit by bit with inspect element. Okay, then what you do is you download some JavaScript. Okay, so what does that mean? So JavaScript means there's some code. The code's not running on the server. If you want a website that has coding that's involved, that executes, you can choose to put the code on the server. So like when you go to the website, the server runs some code, and then it might change the website. It might personalize it or customize it based on the results of the code. Okay, so that would be things like Perl, PHP, Ruby, all of that kind of stuff. Okay, or what you can do is you can give the code to the user and tell the user to execute it. And the user will do it, their browser will do it, and it will do it client-side in their browser using JavaScript or some other scripting language, but JavaScript being the most common, okay? And the main security thing that we need to consider is that once the script starts running, the script is allowed to, like the whole point of it is you want it to like maybe rewrite the content or personalize it. Like say someone flips from French to English, right? Then it's going to, you know, it's going to flip all the words from French to English on the website, okay? How does it do that completely client-side? Well, it needs to have access to all the things that are being displayed, right, in order to flip them, okay? So if you want to think more at a data structure level, you have some scripts, and the scripts can look and see what's in the DOM tree, okay? They can see all the other resources that are on the website. They can read them, and they can write them, okay? Now, we're going to put some constraints on it. So we're not going to say they can see everything necessarily, but that's basically what the same origin policy is going to try and put limitations on. Okay, so the basic story here is if you get a script that's running the correct way, if it gets injected into the website that you're looking at, it can completely rewrite that website, okay? So it can display whatever it wants. It could display a completely different website. It could make a new text box that takes your password. It could log every character that you type into that password box. It could send that to a server. You know, basically it can just sort of, but it's doing this client side, okay? So it's not on the server. So the server is giving you the right website. It's just your browser's loading the right website. It eventually gets to the point where it runs the JavaScript, and then the JavaScript tells the browser, go and change everything else on the website, okay? But this stuff happens so fast that like you would just see, you would see the modified website right away, probably, right? So yeah. So there's nothing wrong on the server. The server is giving you the right website other than this bad JavaScript in the website, and then it can rewrite everything. Question? Yeah.
Are the extensions that we install in our browsers considered as these stuff that changes how the website?
Yep. So one power that you get with an extension is that it's allowed to inject JavaScript into every page that you're on. So actually, you might have seen it when I loaded this website. So see this thing called Zotero connector? It's the second thing that's loaded. It's a JavaScript. That is an extension that I have. So I have this extension called Zotero that lets you save PDFs of papers. If you're ever writing a thesis or something like that, you should use it. But anyways, it's installed as an extension. And because I might want to grab this page and archive it, it's putting some JavaScript into the page itself. Yeah. So different extensions do work different ways. Some browsers give you permissions over extensions as well. But I think by default, like the common understanding is that if you install an extension, it's one of its privileges is being able to inject scripting into every website. So it absolutely applies to here. Yeah. So that's one way you might get a bad JavaScript. In fact, I think I have a slide about all the different ways. Okay, so when the resources come down and put in the DOM tree, there's also a label of where it came from. Okay, or the tree's organized by where it came from. So what does it mean? What do we mean by where it came from exactly? So what we look at when we decide where something comes from is we look at the domain that we got it from. We look at the port number that it came over, and we look at whether it came over HTTP or HTTPS, okay? And so if those three things match for two resources, we say that they're the same origin. And if any one of those things don't match, we consider it a different origin. There's also this override flag that we'll circle back to later, okay? So for example, test.pulpspy.com is a domain. Because it's not over HTTPS, it's probably coming over port 80. It's just HTTP. This is for that override flag that we will just, you can forget about it for now. So this is an example of an origin. So anything else I get from this exact domain that comes to me over HTTP and probably over port 80 as a result will also be considered the same domain. So all of those resources will be kind of clustered together in the tree. There'll be a branch of the tree for just those resources, okay? If I'm loading from other resources, other domains or other origins, then they're going to be in a separate part of the tree. Okay, so it has to exactly match. Otherwise, it is not considered the same. Yeah.
But why port number? Like I understand the protocol and the domain, but isn't the port linked to the specific protocol as well?
Yeah. So I guess they put it in because you technically could get like by okay, so there's default behavior, like HTTP goes over port 80, HTTPS goes over 443. That's default behavior, but technically you could load HTTP over any port that you wanted to. Does anyone know how to do that, by the way? You go to a website, like say I want to go to Google, but I want to get it over port 60 instead, or TSN. So you can go colon. So you might see this, sometimes you see it like in phishing and like weird like URLs. Like, so TSN's not going to give me the website over port 60. So I'm not saying it's going to load, but but that's how you would specify it. So it's technically, it's in the URL, it's just we don't type it. And your browser like puts it there, like it just sees, oh, you're doing HTTP. It puts an 80 there even though it doesn't show it to you. But it is like kind of part of a complete URL. So a complete URL would be the protocol : / the domain : the port number. And so that's why it's that way. And you also have to go back to like this is in 94. And so like the web works a certain way now, but it didn't always work that way back in the 90s as well. So it wasn't as unusual to have different things served over different ports.
Before you'd have the same domain and the same protocol, but because it's not the same port, it would go to somewhere completely different.
Yeah, so the domain, okay, so DNS doesn't consider the port. So you'll always get the same IP address, and you'll always go to the same physical server then, in that case. But the port number is basically used by the server to sort things. So it will just say, oh, you're asking for something over port 80. I'm programmed to send HTML over port 80. You have this other port. Well, I use that for instant relay chat or some other like kind of Gopher, or there were all these like old, like there's also a bunch of things like here, basically you see HTTP and HTTPS, right? Do you ever see anything else? Can anyone name something else that you could put there? Okay, yeah. So FTP might be one, SFTP. There's things like Gopher, there was like IRC, there was, and so back in the day, anyways, a lot of the web has, because HTTP is so powerful, we just sort of do everything over it, but it used to be like different things would run on different ports and have different protocols, and yeah. So this is sort of an artifact of going back. Yeah.
So, say, for example, let's say whichever server is controlling test.pulsepy.com,
Yeah.
I compromise that server.
Yeah.
And I host some malicious JavaScript on another port.
Yeah.
And if this origin policy does not contain port number, like assuming let's say there is no port number, all ports are allowed.
Yeah.
That would sort of lead to an attack, right?
So
that's why like port specifying the port is also.
So we haven't talked about the attack yet, but what would happen in that scenario is the user, would go download everything over one port, and my browser would say all these resources belong together. But then I would get your malicious JavaScript, and it would be over a different port, and it would say, actually, it doesn't belong with those ones because it's over a different port. I'm going to put it over in this section of the tree. And actually, what will end up happening is you'll hurt yourself as an attacker. Because it will be in a different part of the tree. Ultimately, where we're going is that scripting can sort of only see they can only touch the things that are in the same tree, as the same part of the tree as them. So you'll end up isolating yourself. So it's a bad move to put your malicious code on a different port. Okay. Can you change the origin if you wanted to? The answer is yes. So if you want to move up in the domain thing, then that's fine. So for example, what I can do is if the website is coming down from test.pulpspy.com, I could set document.domain to be pulpspy.com. So that's fine because I moved up. I can't move all the way up to .com for the same reason as cookies and SSL certificates and things like that. There's just too many websites in the world. It doesn't make any sense that you want to do that anyways. When I override the domain, it sets this override flag. So it's now true. So for example, this would be the new domain. And technically, because this flag is true, let's say you did download something actually from pulpspy.com, okay? Like it wasn't that it was test.pulpspy.com and it changed its domain to pulpspy.com. You actually got it directly from pulpspy.com, okay? Then it would also come down over HTTP port 80. The domain would be pulpspy.com. But because you got it from them and they didn't override their domain, then the flag would be marked false as opposed to true. Okay? So, and you would be a different domain. Okay? So all the stuff that you get where the flag was set will be marked true. And everything that you get where the flag wasn't set would be marked false. Now, what if you wanted those things to be the same domain? There's an easy solution, which is that even if you're already pulpspy.com and this is your domain, you can still say set document.domain equal to pulpspy.com. So you can set the domain to be what you already are. And so it won't change anything in terms of the domain, but what it will do is it will flip that flag to be true. And now you can be in the same, you can share resources with everything else that also made that flip to the flag. Okay, so I have some examples here that will hopefully help. Okay, so these two things are the same domain, they're the same origin. The protocol's the same, the domain is exactly the same. There's no port number specified, so we assume the default port for HTTPS 443, so we assume that it's the same. I'm assuming there's no overriding or anything like that. Now, let's say that we have, I think this slide doesn't render right. Okay, so these two things are the same. What about the first thing and the third thing? Okay, they have the same domain, but the protocol is different. So one's over HTTPS, one's over HTTP. So these will not be the same domain. This one, even though it's a concordia.ca resource, it's not the exact same subdomain. Okay, so it has to be the exact same domain down to the subdomain. So this is not the same as the first one. Okay, and then similarly, this as well isn't the same as well, the first one or any of the other ones on the slide. Okay, so of these 5 domains, the only two that are the same are the first 2. Now, just to illustrate that flag thing, let's say that you're on Manon's website, and Manon sets document domain to be encs.concordia.ca, and you're also loading resources from encs.concordia.ca, and both operations are happening over HTTPS. These look like they should be the same origin, but they're not, because this one, because it's set document.domain, it has the flag as true. The resources that you're loading here, assuming that they don't do that, then it's set to false. Okay, so these 2 domains are technically different. The 2 origins are technically different. Okay, but if you are running the second website and you want to share resources with this website, then all you can do is you can set document.domain to what you already are. Okay, and then you'll see here the flag flips from true to false, false to true, and so now these are the same domains. Okay, so common Stack Overflow kind of thing. It's like I have this JavaScript running and like I'm trying to see it or it's trying to do something and I'm getting these errors like it doesn't exist, but I know it exists because like I programmed it, and then everyone's like, okay, make sure you set your document.domain to like the highest level domain and do it for all of your all of your pages. Okay, so now let's talk about the actual policy itself. Okay, so the policy will be, let's say we have JavaScript, it's coming down, what origin is it from, and what's the sort of consequence for things that are not from the same origin or things that are from the same origin. Okay, so let's say that I'm on a website, Concordia.ca, it has some HTML, index.html. And one way to put JavaScript into the website is actually just put it in the HTML itself. So you can use a script tag, and then you can just put your raw source code there, and then you can end the script tag. Okay? So let's say that I'm getting this JavaScript. It's in the HTML file, which is coming from Concordia.ca. What's the origin? What origin is my browser going to label this JavaScript as? Not a trick question. Okay, Concordia.ca, right? It's coming from Concordia.ca. It's literally in the HTML page of Concordia.ca, so it's going to label it with Concordia.ca. Okay, a second way that you can load scripts also uses the script tag. Okay, but instead of giving the raw code, all you do is you give a pointer to where the code is. So you say, okay, I have this script, go over to this URL, grab that lang.javascript, and then load it as if it were sort of copy and pasted between the script thing, but I'm not going to actually put the code in the website itself. Why do you do that? It's just a little more modular. Like say you want to make changes to the JavaScript, you can change the one file that's existing on this server, as opposed to going to every single website that uses it, every HTML website, and having to change it in all of those HTML files, okay? So generally you're going to see this. Most people aren't going to put like raw scripts in the HTML itself. Okay, so what do we think the origin is here? Does this change anything in terms of what the origin is? Okay, so I'm on Concordia.ca over SSL. I'm loading a script from Concordia.ca over SSL, so it's going to be the same. Okay, now let's say that instead of having the script sitting on Concordia.ca, somebody uploads it to GitHub. Maybe it's a common library, lots of people use it, and so it's sitting on some third-party server. Okay, so now I'm going to download the JavaScript. So it's exactly the same, it's just that the URL has changed. Okay, what's the origin now? Okay, I think people talked over each other. Okay, so I heard GitHub and Concordia. I guess those are the only two options that make sense. How many people think Concordia? How many people think GitHub? Okay, that's what I expected. Okay, and this, how many people don't know or don't want to guess, are too shy? Okay, if you answer GitHub, you're like 90% of the developers until there was an attack called cross-site scripting that got drilled into everyone's brains, okay? It sounds intuitive that it would be GitHub, right? We changed the domain from Concordia to GitHub. But the answer is actually the minority of you, which is that the domain here is actually Concordia.ca. Or sorry, the origin is Concordia.ca. Why? Okay, so when you load JavaScript, the idea of it is it's as if you're going out and you're grabbing the code that exists here, this lang.js, and you're copying and pasting that code between your script tags, okay? That's what this tag means. It means there's this file here, go grab that code, copy and paste it between the script tags, and then just go ahead. Now we said if there is code between those two script tags, right, then it does get the origin Concordia.ca. Okay, because it's in line with the page itself. Okay, and so it's the same thing here. What this means is it just means the JavaScript you're getting is from some other domain, but you're going to run it as if it were in line with the website itself. Okay, now this is sort of counterintuitive. Okay, one way to convince yourself that this is the right decision is actually to think about the flip. Okay. Let's say anyone can upload any script to GitHub. It's an open repository. Do you really want the scenario where I can upload my script to GitHub. And then when you come to my website, I pull that script down from GitHub, and your browser is thinking that this script has all the permissions of the website GitHub. So like anything else that you have that's from GitHub, it's going to say, well, this script that I wrote and put on GitHub, it should be able to interact with all of those resources and things like that, right? So normally you wouldn't think that, because it's not like GitHub's like exactly giving you the script. So anyways, that might be a useful way of thinking about it. Okay, so the semantics of this is it's as if the script was copy and pasted whatever it is between the script tags. Now the same origin policy itself, I haven't explicitly said what it is, so I'll say it now. If you have scripts can look at the DOM tree, which is just a fancy way of saying they can see every other resource that's loaded on the website currently, okay? And they can change it if they want, okay? So they can traverse the tree, they can change it, but they can only do it for the parts of the tree that belong to the same origin, okay? So if you download JavaScript from origin A and you download HTML from origin B, right, then if, I'm saying this wrong, it depends on how you get the JavaScript into the website as we see, okay? But anyways, if JavaScript is assigned, somehow the browser decides that this is actually GitHub JavaScript, it won't be able to see or rewrite or change anything on the page that was given by any other person that's put resources onto that website. Okay, in your browser, client side. Okay, and if you can access the DOM, there's a lot of damage that you can do. You can basically, like track users' their mouse as it moves around. If they type things in, you can put up password boxes. You can capture those passwords. You can ask about cookies. There's a lot of power that JavaScript has that could be running on the website itself. Okay, now let's say that actually I'll just go to the next example. This will explain it. Okay, the next thing is what we call iframes. Okay, so with an iframe, what I do is I'm on concordia.ca. I have this iframe. The iframe points to, say, facebook.com. Okay, so my browser then goes over to facebook.com and says, give me add.html, okay? And then it comes back to the website, and I've defined this frame, and Concordia, what Concordia does is it defines this frame, and it says, whatever goes inside of this box, Facebook is going to put that stuff in that box, okay? So this is Facebook's like little playground. They can put whatever they want inside of that box. Okay, and so let's say that Facebook decides that, hey, one of the things I want to put inside this box is a piece of JavaScript. Okay, so they load this JavaScript here. Okay, in this case, what do you think the origin of that JavaScript is that's inside the iframe? So you have two choices again. It's either Concordia, because Concordia made the big website, or it's Facebook because the iframe belongs to Facebook. Concordia gave the iframe to Facebook, but now that it belongs to Facebook, then it belongs to Facebook. Okay? Who thinks that the origin is Concordia? No one? Who thinks the origin is Facebook? Okay, everyone else not following? It's okay. Okay, so the answer is Facebook here. Okay, so this is how you actually sort of cross origin. So like if you want to give another website kind of an isolated container in which to run JavaScript and not have it pollute the rest of your website, what you do is you kind of lock it in an iframe. Okay. So Facebook here, which is inside the iframe, it cannot reach out of the iframe and see everything else that is sort of outside of it that Concordia put there. Okay, so it can't read or write any resources that are outside of the iframe. Okay. Similarly, Concordia, they were able to set the iframe to whatever they want. So they were able to say, I'm giving this iframe to Facebook. But once they hand over the iframe to Facebook, they have no idea what Facebook put into the iframe. Okay, they can't see it. they can't, with JavaScript, they can't reach inside of the iframe. Let's say there's a like button, so that if someone clicks on it, they like an article. Even though the like button is embedded in a website from Concordia, Concordia can't like kind of reach with JavaScript. They can't reach into the box and press the like button for the user. Okay, and that's probably what you want. You don't want, every news site that is able to put a like button on an article. You don't want the website to be able to reach in and press the button on behalf of the user. Okay, and so this isolation works for both parties. If you're in the iframe, it lets you do things like buttons, and you don't have to worry about it. And then it also works for Concordia because they're not worried about this sort of spilling out of any scripting that's running here, spilling out and impacting the rest of the website itself. Okay, so on a website like this, let me go back. So on a website like this, it's flat. Everything has the origin, concordia.ca. And on a website that uses iframes, you do have mixed origins now. Okay, so you have stuff from Concordia and you have stuff from Facebook, and it's all kind of hanging out together on the same website as rendered in the user's browser. Okay, so like Concordia, So anyway, so the only person that's seeing this sort of weave together website is the user in their browser itself. Okay, questions about any of this before we think about like things that could go wrong as a result of this? Yeah.
There's something called cross-origin resource sharing that is involved in this as well, right?
Yeah. So there is a kind of override that you can do. I think it's maybe in the slides a little later, but there are ways to if you want both sides to talk to each other, you can do it now. It's sort of newer features. The main takeaway from it is both sides have to authorize it. So Concordia has to say, I want to talk to this iframe, which is coming from Facebook, and Facebook within the iframe has to say, I want to talk to Concordia. If both sides agree to it, then you can pass data back and forth. Yeah, it's not the same as just saying, here's my DOM tree, do whatever you want with it. It's just like you have a way of sending messages, posting messages back and forth. Yeah. Okay, other questions? Oh yeah, actually, sorry, it's the very next thing. Yeah, so you can override it. So there's different things. There's like different ways of doing it. So the way you mentioned is a policy, a content scripting policy, I think. And then this is with JavaScript as well. So you can pass messages back and forth with JavaScript. Okay, so let's think about some attacks on this infrastructure. So there's a big class of attacks, you've surely heard of them by now, called cross-site scripting. Okay, and cross-site scripting is basically just a direct result of this policy. Okay, so we wouldn't have had browsers, Netscape wouldn't have had to do, they wouldn't have had to set up these policies exactly like they did. They could have made different decisions, and it might break certain features that we expect from websites, but at the same time, it might have eliminated these kinds of attacks. But anyways, a lot of these attacks also are, it's kind of like when I asked the question and most of the class was wrong. A lot of these attacks are because the developer of the website thought the website worked a certain way, but it actually works a different way. Okay, so the mental model of the developer was different than the actual mental model. And so a lot of these attacks have gone away because now developers know they have the right mental model because it's drilled into them because there's been so many different problems with this type of thing. Okay, so the main idea is, so cross-site scripting simply means that I get my script, which is not on your domain, running on your domain. Basically, I'm able to inject my script into your domain. Okay, so that's the cross-site, is just that the attacker has a script sitting over here, here's Concordia or whatever itself, and somehow it's crossing over, okay? And it's as simple as getting the website itself to basically load my JavaScript. Even if my JavaScript is on some third party, because it's being loaded, not in an iframe, it's just being loaded directly into the website, then it's going to run with the origin and all the permissions of the website itself, and it can see every other resource that belongs to concordia.ca in the current view of the website, and it can change any of those resources as well. Okay, so there's different ways of doing cross-site scripting. We'll talk about a couple of them. My goal here isn't to like teach you the attack. You'll take a networking security course, and they'll go through like lots of different sort of mechanically how it works. I'm just trying to show you like how the policy creates different types of attacks, more or less. So we're going to look at it kind of from a zoomed out perspective. We're not going to sweat a lot of the details of how it works. Okay, and we're going to include very simple things too. So a simple thing would be, let's say there's a very popular library that lots and lots of websites use, and let's say it's on GitHub, and somehow I'm able to change that JavaScript file on GitHub. Okay, I steal the credentials, the login credentials of whoever maintains it. Somehow I hack GitHub servers. I don't know. There's lots of different ways I do it. Once that malicious website or that malicious JavaScript is now malicious, then every website that loads that library will be vulnerable to cross-site scripting. Okay, it'll be vulnerable to whatever I'm doing in my script itself. So that's a very simple way of doing it. Another way you could do it is GitHub might have the real file. So there's a real lang.js. Again, it's a popular library and everyone uses it. And I can't change the file on GitHub itself. But if GitHub is giving that file over HTTP and I'm on the wire, then what I can do is when I see the real file go by, I can swap it out for my malicious file. Okay? Then the user will load my malicious file instead. Because it's HTTP, it won't get caught. It's not over a tunnel. And so I'm able to do that. Okay? Then it's the same consequence. They'll load my malicious website, my malicious JavaScript, and then I can completely take over the user's view of this particular website. Okay? Now, if you remember back from at the start of the term when we talked about HTTPS, we said now browsers will not let you load JavaScript over HTTPS. Okay, they will just straight up block it. You can try and do it, it's fine, it will just get blocked. They won't run it, they won't warn the user, they won't ask, they'll just straight up block it. And this is the reason why. It's because if you, the risk of downloading a malicious JavaScript is just too great, okay, because it could just completely re-render the website itself. So browsers won't even let this attack happen. Another thing you can do is you could try to embed the JavaScript into the content of a website that you're allowed to access. Okay? So imagine you have some social media platform and you're allowed to like change your bio or your name or your location. And so you set your location to code, like script, like a script tag with like some actual JavaScript inside. Okay? Then what you're hoping is that another user comes and their browser basically gets tricked. It's kind of like parsing the HTML, and then when it hits this bio that you've set, it says, oh, that looks like an HTML tag, right? That's not like, I'm not supposed to show the user triangle bracket script triangle bracket. I'm supposed to execute that, right? So basically the browser is sort of confusing what should be a passive resource, text that should be displayed to the user, and what's an active resource, which is something it should execute. Okay? Then it might actually execute that code itself. Okay? So this is like probably the very earliest web viruses or whatever you want to call them were of this nature. Okay? We call it persistent cross-site scripting because it's stored on the website. Every user that goes back to the website will execute it. There's early social media websites, like there was one called MySpace. It was kind of like music oriented, and someone was able to do this. They figured out how to do it. And some of the actions that you could do over JavaScript once you got running in the same origin as MySpace is you could make the user who's looking at your profile follow them. So that was one thing they did. And then another thing they did is you could do over JavaScript is you could change that user's profile to also embed this JavaScript. Okay, so basically one attacker put up their profile with this hidden JavaScript. They got one other person to visit their profile page. As soon as they did, that person followed them, and they updated their own profile page to make everyone else do the same thing, to follow this one person and to embed the JavaScript. And so then it spread. And soon, like basically everyone on the whole social networking was following this one person, and everyone had this like JavaScript running on their profiles. And it ended up creating a whole bunch of extra traffic, and the database couldn't keep up. The website went down. And I think the person who did it actually like got into legal trouble for doing it. That's my recollection. I might be wrong on that. Anyways, yeah, so this is called persistent cross-site scripting. Now, this is very, very hard to do today, okay? Because everyone knows about this. We've known about this for 20 years. So when you use, most people don't like design websites with raw HTML. If you did, then you might fall into this trap. But usually you're going to use some sort of web framework, and that framework knows all about this attack. And it's not just going to do one thing to stop the attack, it's going to do like everything it can think of. So like in general, you would never even be able to put a triangle bracket. Like it would just say that's a character that you're not allowed to use in any user generated string. And it would, whatever you submit, it will parse through, and it might delete things, or it might say that looks like scripting, so I'm gonna, remove it, or I'm not gonna allow you to do it. It will present in the HTML any user inputs will get presented in a way that the browser will never confuse it for code. Okay, like it is possible, like say you go to a how to program website, you can see I'm not explaining this very well. Let me. So you can see on this website, like there is this literal script thing. Like this is in the content of the website, and my browser isn't like, oh, that's a script that I need to execute. Like it knows that that's text to display to the user, okay? So there are ways to unambiguate what is code that should be executed and what is text to be displayed. Okay, another kind of cross-site scripting, another way to get your script injected into a website goes back to this sort of RESTful architecture that we talked about last class. So a lot of websites, for example, if you go to google.com search and then there's a query, there's a place to put state into the URL so that if a user goes to that particular URL, then Google knows, for example, what was the search term. Okay, so it says, oh, this person's searching for script code, end script. Okay, now is this cross-site scripting? Is this code that your browser would execute because it's in the URL?
In certain cases, if, like, for example, if that does not return any results, then it will show it that this did not return any results.
Okay, good. So in the URL, it's not dangerous. Okay, having scripting, even if your browser is going to get confused and think that this is script, because it's in the URL is part of the header, it's not part of the body of the website. Okay, the problem with it is when Google decides to take that search term out of the header and put it into the body of it itself. So it might do that, for example, where it might say, okay, sorry, there's no results for, and then the website is just programmed to like whatever this query term is in the URL, I'm just going to drop it into this space, right? So now it's in the content of the website, it's in the resources, and so as a result, if the website was programmed in such a way, it would get confused about it. Okay, so this is we call it reflective cross-site scripting because we're reflecting something from the URL into the content of the website. The typical attack would be you just get an email, it would say click on this link. It would try and entice you, like you'll win money if you click on this or whatever, and then you click on it, and then now you're on a website and the adversary's JavaScript is running, and then it's up to them to do whatever they want with that power. Okay, so here you can see this is like an example of it. Now Java, this doesn't work on Google, right? So Google does show me this, but again, Google is programmed in a way that's hardened against this. So when they show me this search string, they've made it very, very clear at the HTML level that this is not to be confused for HTML. This is something that is strictly to be shown to the user as part of a text resource on the website, as opposed to, something that should be executed. Okay, so is there any questions about these three so far? Okay. The next one I'm going to show you is like a very, very elaborate cross-site scripting. So my goal here isn't to show you every flavor of cross-site scripting. There's probably 10 or 12 of them. I think in 6-120 or 30 or some other course, I think they go through a bunch of them. So you will learn about them. But I just wanted you to see the sort of conceptual differences. And the main point I want to make with the next one is that attackers are very creative, right? So they'll do whatever it takes. These ones are pretty simple, and they're things that we've sort of known about. Okay, so you could just overwrite the JavaScript where it's hosted. You could try to intercept it in flight and change it. You can try to embed scripts on websites that you're allowed to embed text on, or you could try to reflect it in. And then on the other extreme of like the most complicated attacks, I'm just going to show you one just so that you kind of see, just to sort of illustrate the point of like the extent that adversaries will go to try and make these kinds of attacks work. Okay. So what happened is if we go back to these persistent cross-site scripting, as I said, websites, web frameworks, and things like that, they scrubbed out, they basically went through, sometimes with automated tools like static analysis tools, and they just said, show me every single field, every data like variable on my entire website where a user could put a value there. Okay, and then they go through one by one and say, okay, we want to sanitize this, make sure they can't insert coding, and if they insert coding, then we're going to display it as text as opposed to actually execute it. Okay, and so people started overhauling their websites doing this, and what they started with is they started with like the most important case, which is any text that I can write into the website that would be displayed to you. So I change my profile, you come to my profile website, so you see the text that I supplied in my profile. Okay, that was the most important one to fix. Okay, there were other parts of the user interface that are usually like in settings or things like that, where sometimes there's you take text from the user, but you only ever show it back to the user. You don't show it to any other user. So for example, let's say that I'm putting my email in my profile and it's saying like, this is never shown to the public. Like it's just a private thing. If I log into my profile, I'll see whatever I stored as my email. But if there's no way that you could possibly see my email because it's in my profile. Okay, so there's, we call these admin panels and backends, and they have these, they are fields where the user can put whatever text they want, but it's only ever shown back to the exact same user. Okay, is it dangerous if I can embed a script into here? So let's say I can do a cross-site scripting attack where I can put, instead of putting my email here, I put a script here. What's the danger? Where is the attack if that were possible? So I would store a script, yeah.
So what if, let's say there's a user, and I as an attacker tell the user, okay, let's say you please put this in this, and like change it, and that will actually lead to like a execution of malicious code against the user, but only if like I'm able to coerce him into putting it himself.
Okay. So I could try and trick a user to put the code in their own profile, And then every time they view that website with that profile, then that code would run. So that's correct. I agree with that. Is there anything else I could do that doesn't involve tricking the user? So in normal cross-site scripting, remember, it doesn't, it's like I put it on my profile, all you do is come to my profile. Like usually I have to trick you to go to like a particular website, but beyond that, I don't have to tell you to do weird things in terms of your settings. Okay, does anyone feel like, well, everyone feels like there's probably an attack here, otherwise I wouldn't be showing it to you, right? But does anyone get the feeling that it doesn't seem, at least at first glance, it seems like there isn't an attack here? Okay, why wouldn't there be an attack here? If I put cross-site script, if I put a malicious script in a place that I'm the only person that can see it, who's the only person that I can attack with that attack? Is myself, right? So I could do it, I could put it there. If I go back to the profile and it displays it, then I'll attack myself, which is fine. So there is an attack there, but it's dumb because I'm just attacking myself, okay? I can't weaponize this against you, okay? So that's the first glance of this. So people thought for a long time, let's leave this stuff till the end. We should probably fix it anyways. It's just not good. It's not sanitary to like have people be able to put scripts in. But if it's some field that's only shown back to the user themselves, at best they can just attack themselves. And so that's not a high priority for us, okay? So a lot of websites, they spend a lot of time sanitizing all the public-facing tech stuff, but not these back admin panels. Okay, so here's the kind of attack that you can do. What you do is you first trick a user to come to your malicious website. Okay, so this isn't going to work unless if you can trick them into doing that. Okay, so you send them an email, you entice them, they click on the link. Now, generally, if you just go to a malicious website, it shouldn't harm you in any way. That's the model of the web that we all want to believe, right? Is like you can click on links. You might see things that you don't want to see, but like there shouldn't be any like kind of lasting harm to you. It shouldn't be able to like, I don't know, steal the money of your bank account or change your Facebook password or whatever. Like it should be like contained to that website itself. Okay, so cross-site scripting kind of violates that. But anyways, okay, so what the adversary is going to do is they're going to pop up a website. They're going to get the user to come to them. They're going to create an iframe. Okay, and what they're going to do is they're going to load that administration panel, right, which has that information stored. Actually, sorry, before I get there, they're not quite yet. Okay, what they're going to do is they're going to, so let's say that this admin panel is on Twitter or whatever. Okay, the first thing I'm going to do is I'm going to load an iframe and I'm going to say, go to Twitter to your profile on Twitter. Okay. Now, if Alice, the user, is logged into Twitter, right, when this request goes to Twitter, it includes her cookies because the browser is throwing those cookies in. Evil.com they don't see the cookies themselves, okay? But what will happen is the iframe itself, the browser will go out. It will say, go to Twitter. It will say, give me this user's profile. By the way, here's a bunch of cookies I have for this user. Twitter will say, I know who that is. That's Alice. I'm going to show them their own profile, okay? So we have this iframe, it's sitting here, and Alice's profile is inside the iframe, okay? Now, because of the same origin policy, evil.com they can't reach into the iframe, okay? So let's say I want to know who all of Alice's friends are or who liked her tweets recently, okay? I can't, if I'm evil.com, even though I trick you onto my website, even though I can make you load Twitter, and even though you're logged into Twitter when you load it, because of the same origin policy, I can't reach into this iframe and actually look at your tweets or look at your friends or anything like that. Okay? So there's this is isolated, the iframe's isolated from the outer contents. Okay? But I'm not done yet. Then what I'll do is, this is just showing that the adversary can't reach inside. What I'll do is I'll load a second iframe, okay? And assuming that Twitter uses kind of like RESTful architecture, what I could do is I could say, okay, the user wants to log out, okay? And normally they would click the logout button, but that logout button would have the logout action in the URL so that Twitter doesn't have to know that you press that button. It just sees a request come where sign out is in the URL and it has the right cookies and it says, okay, now the user wants to log out. Okay, so I load a second iframe. I have a URL. It has sign out equal to true. And so now the user's signed out. Okay, but this first iframe is still sitting there. It doesn't like refresh the website. Okay, I could do that if through JavaScript, but I'm not doing that. Okay, so the user's profile is still sitting, or sorry, the user's like timeline is still sitting here, but they're in the second iframe they're now logged out. Then what I could do is I could log in again, perhaps using RESTful tags. So I could put my username, I could put my password, and I could log in, and I could log into that admin panel. I could log into my account. Sorry, I'm being the adversary. So the adversary does another iframe that says log into the adversary's account, okay? And go to the admin panel for that profile, which is the adversary's profile, okay? And that's where they've stored this script that only they can see, all right? And so now that script starts executing in this iframe, okay? So the script is executing in this iframe, okay? Now, we said that the adversary, evil.com, can't reach into this iframe, right? Here's my question to you. Can the JavaScript that's running in this third iframe reach into the JavaScript that's running in the first iframe? What do you think? I don't expect you to know the answer. Okay, so one answer could be no because they're different iframes. So every iframe is isolated. Okay, what's the origin of all the resources that are inside this iframe? Like twitter.com or x.com now, I guess. Okay, what's the origin of the script that's running here? It's the same. It's x.com, right? Are they the same origin? Are they on the same website? So are they in the same DOM tree? The DOM tree applies to the whole website. So the iframe is like an element, a resource of the website.
Are there frames in different DOM?
So they're not. Yeah. So everything gets put in. An iframe is just, it's an element of the tree. Okay. And everything in the DOM tree that's labeled with one origin can access everything else that's labeled in the DOM tree with the other origin. Okay. So the answer is that yes, this script can reach into any other iframe as long as it's the same origin. Doesn't matter, okay? So all the iframe didn't, it wasn't the thing that isolated anything, okay? What the iframe did is it forced all the resources to be from a different origin, okay? And then the browser said, because you're from a different origin, we're gonna isolate you, okay? So the iframe isn't directly isolating content. The iframe is just making sure that things have different origins, and then the browser's saying everything with different origins is isolated, okay? But here what I've done is I've created a bunch of iframes, and so everything here is labeled one way, but everything here is labeled the same way, okay? So they're not isolated from each other. Does that make sense? Okay. So so unfortunately the script that's stored here, even though I'm the only one that can see it, if I can somehow through JavaScript get some data I want to steal from you, use a cross-site request to get that data into an iframe, log you out just using RESTful architecture, log myself back in using URL parameters, and have one of these I forget, there's a name for this kind of cross-site scripting. Okay, self-infected cross-site scripting. If I can have one of these vulnerabilities in the website, so if I can thread all four of those needles, then I can actually attack you, okay? And is this going to work on every website? Probably not, but did it work on at least one or two websites? Enough that somebody filed like a report about this attack? It did. Okay, so everyone knows about this attack because it did work on at least a couple websites. Yeah. So, Okay. So the question is, what about the second iframe? The first thing I want to say is that the reason I did this in 3 iframes was just so that it would tell a better story. Like the person did this and then did this, but you could actually do it all within the same iframe. They don't have to strictly be different iframes. So when I load the second iframe, my browser says, okay, they want an iframe, and you're going to go out to this particular URL, and whatever this URL sends back, you're going to put into this iframe, okay? Then your browser will say, do I have any cookies for twitter.com? I do, okay? So Alice's, and it will belong to Alice, because it's Alice's browser. So that URL goes to Twitter. Twitter looks at it and says, okay, somebody clicked a logout button. I see that from the sign out. I know it's Alice because I have her cookie. I'm going to log Alice out. Okay. You mean this script here, right? Okay. Yeah, I understand what you're saying. Okay, it's a good question. Okay, so I load this iframe, then I log Alice out. The adversary logs in. The adversary gets their script running. Now that the adversary script's running, can the adversary go and start asking about all of Alice's stuff? Like, give me Alice's friends and profiles. It can't because Alice is logged out. Okay? So I didn't explain it very well, but the whole idea is before you log Alice out, you get everything you want to know about Alice loaded into this first iframe. Okay? And then because the website doesn't refresh, this stuff is still sitting there. So even though the adversary is not logged in as Alice, it can't ask for new stuff about Alice, but whatever the website loaded when Alice was still logged in, it's still there for it to see. Yeah? So there's a distinction. It's not that the script is going out to Twitter and saying, give me Alice's stuff, and then learning it. What it's doing is it's going from the third iframe to the first iframe and just say, show me what was loaded in the first iframe. That's what it's allowed to do. Does that make sense? Yeah. Okay. Yeah.
So the third iframe could have access to the DOM tree of the first internal iframe?
Yes, exactly. Yeah. So on the DOM tree, all the resources loaded in all 3 iframes have access to each other. Read and write. Yeah.
Like the script can be written in such way that load the Twitter profile of the user who is to visit myevil.com and then send it to my website. So, like, is there any necessity to log him or her out
The-
from the Twitter?
The only reason the logout exists here, just you have to get this browser logged into the adversary's account in order to see the admin panel, because it's this cross-site scripting is sitting in the admin panel, and it's only in it's only shown to the person. Like if I create this account, I put my script there, it will only be shown to me when I'm logged in. If you go to this exact same website, it will show your email that you left, right? Yeah. Okay. And then sorry, I lost the question.
Here what I can understand that we crawl all the data from the loaded iframe,
Yeah.
send it to my website.
Oh yeah, sorry, yeah. So in the third, that's okay. That's another good point. So the script can read everything in that iframe. So what? So it reads it, but the script is running in this browser window. As soon as the user closes that browser window, then it's gone, right? Yeah. So sorry. The implicit assumption is that the script here, whatever it's reading out of iframe 1, it's sending off to Eve's, like a server that Eve has put up in order to collect that information. Yeah, I should make that. Oh yeah, sorry, I do have it here. Okay, so these are considered the same origin. The script in the third iframe can read the data in the first iframe, and then the script in the third iframe can also send it to an adversary-controlled server. Okay, other questions about this attack? Okay, I'm going to keep going. I'm going to push through the break because we're going to end early. There's only like maybe a few slides left. So that's. Okay, yeah, and it's called the self-inflicted cross-site scripting. The original attack. Well, actually, maybe this whole elaborate thing is called self-inflicted. But this specific thing, I think, is where that term comes from. Okay, one other attack I want to talk about that's relevant is we talked about this like button. All right, so let's say that Eve tricks you into going to her website, and she loads an iframe from Facebook, and it has this like button, and Eve really wants you to push that like button, okay, because then it will like her page, and then other people will see her page, okay? Can Eve use JavaScript to reach into that iframe and click the like button? It can't. Why?
Because it's for the source or
Okay. So it's cross-site. The origins don't match. This iframe, this Facebook like button is a resource that belongs to Facebook, which owns this iframe, and it has Facebook's origin. Everything outside the JavaScript that might be running out here trying to reach in would be assigned originevil.com, and so they can't see each other. Okay. Okay, great. Is there anything I could do to get you to click on that like button so I can't reach in?
Yeah, let's say you make something really appealing appear on the iframe, and then on the iframe tag itself, you just put on click equal, and then you put on the script. Then if the user would click on the iframe, it would execute the script.
Okay, so I just want to make sure I understand this. You want to have the JavaScript outside of the iframe.
Well, no, it's actually it's part of the iframe tag. The iframe tag
Okay.
just puts on click and then put your JavaScript here. So it would so as soon as the user would click on the iframe, it would execute the script as part of the website itself.
Okay, and then this is a little different than what I'm thinking. That's why I'm asking questions. But when you say the script, what's the origin of the script?
That would be evil.com.
Okay, so so on click it would. So if the user clicks anywhere on the iframe, a script that has origin evil.com would start running.
Yeah, the same way. For example, if you put like a source tag on an image, when you click on the image, it would actually lead you to the source tag.
Understood. But why can't I just run that script anyways? You're already on evil.com. I don't have to wait for you to click on the iframe. I could just straight up run it.
Oh yes, because the unload properties don't have the kind of consensus that it's an action done by the user. But if the user clicks on the iframe, it registers as a user action, and therefore it says that you have like a consensus of the user to execute that script.
Okay, so the script might have additional permissions that are granted to it by the browser because they took an action to do it, but it still doesn't tell me how I can reach, because the JavaScript's still isolated from the like button. Yeah?
It's not really related to the content inside of the iframe, honestly.
Yeah. Right. Okay, so clickjacking, I know the name, you might have a pre-existing notion. The attack I'm thinking of is different anyways. But anyways, there may be an attack there, but I still see trouble getting something with originevil.com to be able to influence something with originfacebook.com. Yeah.
So, like two things. I think the attack may be possible when, if and when email.com and facebook.com has that course relationship.
Okay, so there could be some like agreement, but would Facebook ever agree to share resources?
What if Facebook agreed with a certain type of domain, which not email.com, something else, it already has an agreement with a domain like that, and I take a subdomain from that, then maybe that's possible.
Perhaps. So Facebook could get tricked, but in general, they're not going to share this kind of thing because it's the integrity of the whole thing is built on that it's isolated. Yeah.
And secondly, like as you said, it's about making the user click on the iframe.
Yeah.
So you could just have simple HTML code that like overlays onto that iframe and makes the on something, but they're actually clicking on like the Facebook like button.
Okay, great. So this is a much lower tech example, but can I put an image over that iframe?
Yes.
Okay, you say yes, but that's not obvious to me. I mean, I said, like, when you define an iframe, you actually say, like, these pixels by these pixels. So doesn't that belong to Facebook? How am I able to put an image? I set aside this, like, actual real estate on the website and said that Facebook can put anything they want. Like, a frame is, like, it has a structure, right? So are you sure that I can put an image in the frame? Okay. All right, so the answer maybe is surprising, but you're right. You can put an image. You can try and overlap an image with a frame. Let's put it that way. Okay, so you can say, I want an image to be, on these pixels, and you can say, I want an iframe that's on those pixels as well. Okay. Okay. Now here's the next question. Let's say that you have a conflict where the high level evil.com is saying put an image here, and it's saying put an iframe there, or maybe in the opposite order. What does the browser show you? Let's keep it really simple. Let's say that Facebook's just putting an image here. It has an image of a cat. You're trying to put an image of a dog in the same real estate as the iframe. When the user looks at it from the browser, do they see the cat or do they see the dog? And the dog, I've already confused myself. The dog is the evil.com?
Yeah.
And why? But why? How does it end up on top? You mean like the code is on top? Does it have to do with the order? So like if you load the dog first and then the iframe, or the iframe and then the dog?
Because it tells your browser to.
It's like the order of the code execution.
Okay, so the HTML, like one of those things would have to be defined first, right? So does it layer up or does it layer down? Okay, so one thought is that it layers up. So if I put an image there, then I put another image on top, then the one that's on top will show. Yeah? Everyone agree with that? So let's assume that that's true. Then how would I get my image on top of the iframe? Do I load it before the iframe or after the iframe? After the iframe. Okay. So the true answer is that yes, what you say is correct, but also you can specify it. So you can actually use CSS to just, you could even define it first and just say, I want this on top. Okay. So there are in the scripting, in the style sheets, there are notions of like things layered on top. And so you are able to layer things. You can say that this is the top layer of the website or whatever. Okay. So, and you can overlap iframes and other resources if you want to. Okay. So your browser is not going to stop that. All right. So if you want to put a big click here and win, button on top of it, you can do it. Okay. But there's one other problem that we have. Okay. I have a like button here, and it's on the bottom layer, right? I'll just put this here. So I have this like claim prize image that I slid over top of that like button, okay? But I still need the user to click. So if this image is on top and I click on it, I'm clicking on the image now because the image is covering up the button. It's no longer a button, right? Like if I clicked on that and dragged it, is it going to like click the button underneath or is it going to drag the image? What do you think? It's going to drag the image, right? Because the image is on top.
Like we can just put the text price and no action on it. So when it clicks on it, so actually it clicks the line.
Okay, so that's one idea. So we could have something that like isn't, something that is enough to obscure it, but when you click on it, you're going to click through it somehow, like text. So maybe that works. Okay, another thing that we could do is because style sheets are so powerful and they give us so much power, is you can actually, in the style sheet, say, I want a transparent click. So a transparent click means that if the user clicks on it, it clicks through it. Okay, so that's one of the powers that style sheets give you, And so what you can do is you can actually create an image. You can say, I want it on top. I don't want it on the bottom. I want it on the top. I know it's going to overlap an iframe. I know I'm not controlling the thing that's under it in the iframe, but just do it anyways. Just put the image there. And by the way, if the user clicks on that image, then I want you to send the image through. Or sorry, send the click through it. I want it to be transparent click. Okay? Why is scripting so powerful, or why is style sheets so powerful? Who knows? Right? Some developer somewhere thought that this was a good idea once upon a time. Okay? But it leads to like these really simple attacks. Okay? So what I can do is I can layer that button over top. Now you click that claim prize. You don't even see that there's a Facebook like button loaded. You don't even know it. And then all of a sudden, you're now doing a cross-site request. You go over to Facebook because you click the like button. You're logged in because your cookie gets sent along. And Facebook's like, oh, you must have clicked the like button, right? And then it reposts that on it. And then later you log into Facebook and you're like, oh, why is this weird article on my feed? I don't remember posting that. I must have got hacked, right? And so in a sense you got hacked, but it's not like someone broke your password and logged into your account. It's just that you clicked on something dumb on a malicious website. And so there was a period of time where people were very convinced that they got hacked in the sense that someone stole their password, but really they were just falling prey to clickjacking. Okay, how do we fix this?
Disable warning ad block.
Sorry, say it again.
Like it's possible to disable warnings.
Okay. So we can, do you want to disable the, what exactly do you want to disable? Like the overlay or the transparent click?
Either one of them.
Okay. So the iframe itself could have something that says, don't let anyone overlay me. So I think that that's part of the content security protection. We could also turn off transparent clicks. It seems like something that's not that useful anyways, right? Another thing we could do is we could just have the browser kind of look out for this kind of attack. It has a pretty telltale signature, right? You have images that are transparent, which you almost never see, with transparent clicks, I should say. You almost never see them. And they're loaded over top of an iframe, something else that you don't typically see. So those are two like very unusual things, right? And if you ever saw the two of them together, you might say, this looks a lot like clickjacking. Why don't I just, I'll be safe and turn off transparent clicks, and then that will get rid of it. So you can get browser extensions that will do this for you. Or my understanding is actually that browsers basically don't allow transparent clicks anymore. I think that's a feature that's maybe like just disabled, and so you can't do it. And there might be some extent to which the iframe, with some of the newer additions to browsers, could write a policy that says don't let anyone put an image over top of me. So I think all three of those things are true. Okay, so what are some lessons that we can learn from this scripting stuff? Did you have a question? No. Yeah.
The ad blocker extensions, are they gonna block the iframes, or they gonna allow?
So generally iframes are good. You want follow buttons and like buttons and things like that. You want so maybe, I mean, it's one thing an ad blocker could do is just indiscriminately block iframes. It could also block the cookies, which means that there would be a like button, but when you click it, it's not actually your like button. So there's a bunch of things they might be doing to stop ads or stop tracking that would sort of accidentally kill this clickjacking attack as well. But those are the types of extensions that also will have this built in to look for clickjacking now. So they'll also just look explicitly for clickjacking and then stop it if they see it. But I do think ad blockers generally, they let iframes go through because there's so much useful things that you can do with iframes. They're not always bad.
And that transparent clicking, are they gonna allow these too, or?
Yeah, so I think an ad blocker that saw transparent clicking would probably just turn it off. I think that would be the default setting. So I'm not 100% sure, but that would be my best guess at what happens. You'd have to check for sure. But yeah. Okay, so policies, it's hard to get them right. There's usually loopholes. We saw loopholes in the airport policy. We didn't see like loopholes per se in the same origin policy or in the cookie policy. But what we saw a lot of is like the policy didn't make intuitive sense. Like your first guess at how it works was different than how it actually worked. And then that can lead you into trouble. So developers have to have the right kind of mental model of the policy and how it works. We don't have a great methodology for policies. Okay, so if you're like, hey, I wrote this cookie policy, is it good or bad? Or I want it to have certain properties or not have certain properties, or I want it to be like so that there's no possible way that a cross-site script could ever execute in this environment or whatever. You can ask the question, but like, how are you going to figure out the answer, right? And so we have lots of methodology for like, I wrote a piece of code, is it secure or not? I can do static analysis, I can do all sorts of different things, but I don't have the equivalent for policies. Policies, once you write a policy, it's hard to change it. Okay, so like when Netscape set these policies in the 90s, then there was a big period where there were all sorts of cross-site request forgery attacks and cross-site scripting attacks. Netscape could have said, you know what, maybe we need to change the policy. That would be one way we could get rid of all these attacks. We'll just change what the policy is. The problem is that's going to break all sorts of websites that are following the policy, that have the right mental model. Okay, so once you implement a policy, sometimes it's hard to change. You have things that aren't backwards compatible. Sometimes it doesn't matter. Like the airports, when they started checking IDs at the flight counter, that was an easy policy. There was no backwards compatibility issues, other than maybe people, forgot to bring their IDs or something like that. Developers usually just want things to work, and so they'll go on Stack Exchange, Stack Overflow, and just be like, how do I fix this? And everyone's like, oh, make your document domain the highest possible domain, make all your cookies star.your domain, set their expiration date for 30 years, make everything as permissive as possible so that everything has the best chance of seeing everything else. You can design things that way, but it's not a very sensible design. It's better the security people will tell you should design with what we call least privilege. So you should give something enough privilege to do what it's supposed to and no more, right? That's like the least privilege. You can have overrides. So we saw this before, like where you can change your domain, or like two websites can agree, we're going to override this policy and things like that. But now what you're doing is you're actually adding another additional layer of complexity. So the policy is even harder to understand now because you have these override conditions as well, and they're different from the non-override conditions, overrode conditions. And so, yeah, it just can be harder. The more complex the policy is, the harder it is to figure out whether it has loopholes or it's missing things. One thing I wanted to mention that I guess I don't have as a bullet point is one methodology you can use for analysis is you can treat policies like code if you want them to. So you can take a policy and you can write it out usually you'd use a language that's used for describing logic. And then what you can do is you can tell the computer what are the properties that you want to hold in this system. And then the computer will try every combination it can to try and find examples where that policy doesn't hold. Okay. Now, there's a couple problems with this type of approach. So we call it formal methods or formal verification. The first problem is that you don't model it correct. So you have your policy, and then when you write it in terms of code, you miss things. So the code version of the policy is correct, but the real policy is slightly different. It's not correct. The second thing, I think we mentioned this also with social engineering, is that sometimes people don't follow the policy. So the policy is written down, and the policy is fine. It's just that when you get a human on the phone, they'll do something that the policy tells them not to do. And then the other thing is it's just a lot of work that can't be kind of replayed. So if you take an airport policy and try and code it up, and then tomorrow you're like, I'm going to do the same thing for the same origin policy, you can reuse almost zero of the work that you did the first time. Okay, so like you basically have to start from scratch because they're completely different things. So people have done this. So for example, one example of a language Let's see if I can remember the name of it. Yeah, so the name of it is escaping my mind. It's a project from MIT. There's a bunch of different ones of these. But anyway, there were some people that like one of them was a Google engineer, and they did the same origin policy. And so they modeled it. They took it exactly out of Chromium, and they put it into this formal verification language. And then they asked it for all sorts of conditions, like make sure that things are always isolated. There's never a case of this. And they found lots of vulnerabilities. So I think they found like 5 different things that nobody had thought of before. And they were pretty complicated things, but if you did the right thing in the right order, you could get it to like sort of violate the policy. The other problem with this formal verification is that you have to try every possible version of the universe, right? Like in this version, if I do this thing in this order, is there an attack? And then you have to keep trying it. And a computer cannot try every possible version. So what the computer does is it uses heuristics to sort of say, I tried this thing already. If I try all these other things, it's more or less the same thing, so I'm not going to bother to try it. But that's not necessarily true either. So your computer that's doing the analysis is also limited. It's constrained. It can't try every possible combination. So it's going to make some decisions about which ways to try it, but it might miss things that way as well. Okay, are there questions about the lecture itself? Okay, good. And I'll just circle back to the final or any of the logistic stuff now that you've sat for half an hour. Is there any other questions you wanted to ask about that come to mind? No? Okay, good. So thank you. It was a fun course. Your projects you will submit through Moodle. Just pay attention to the like the naming of the file and things like that. And the marks I should mention is that I won't give your project mark back to you. You'll just get a final grade. Okay, it will include the exam and it will include the project. But if you're curious about it, you can shoot me an email and say, can you give me the breakdown? And then I'll send you back like what it was for the project and what it was for the final. And then if you want to review your final exam, you can do that as well, but it would be like in January because you would come in person and do that. So you can also email me next term to set up an appointment to do that. Okay, good luck everyone, and I'll see you in a couple weeks.